Alright people, this is where we were in the previous video. Now, I had asked you to work this out and see if you got the answer that I had got previously when I worked it out. Now, let's look at the solutions. Alright? So the angle of depression. Alright, let's say you have, so the cliff is here, and this is the sea, and you have the jet ski here. Say this is the jet ski. Alright? The angle of depression from the base of the cliff to the jet ski is 45 plus or minus. Alright, so you remember, angle of depression is the angle between your line of sight and the horizontal. Say it is theta. Plus or minus is 45 plus or minus 0.5 degrees. The cliff is 350 meters tall plus or minus 0.2. So it's 350 plus or minus 0.2 meters tall. Alright? Now, estimate the distance. Let's call it x. Or could you say d? D for distance. Let's estimate the distance of the cliff from the jet ski. Okay. Now, theta equal. Remember now, the angle should be in radians, alright? So let's convert it. Remember, one complete revolutions contain 360 degrees, which is 2 pi radians. So if 360 degrees is equal to 2 pi radian, when we divide both sides by 2, we get that 180 degrees is equal to 1 pi radian. 1 pi radians. Now, if we should divide both sides by 180, I mean 180 pi radians, I should say. Did I say 1 pi? If we divide both sides by 180, then we get 1 degree is equal to pi over 180 radians, right? Let's get rid of this. Pi over 180 radians. So if you multiply this now by 45, remember it was 45 degrees plus or minus 0.5 degrees. If you multiply this by 45, we get 45, and this must also be multiplied by 45. So we have 45 pi over 180 radians over here. Alright? So 45 degrees is 45 pi over 180 radians. Right? And as for the margin of error part, plus or minus 0.5 degrees is the same as plus or minus 0.5 pi over 180 radians. Alright? Now, we need the thing there, the angle. No, the formula. But before that, let's calculate the nominal value for D. Alright, so how does this go now? If we have this as angle, this is also going to be theta. Right? We say same as what is up here. Now, let me see now. Now here, tan theta is the opposite 350 over adjacent, which is D. We want D. So you know D would be equal to 350 over tan theta. Same as 350 times the cotangent of theta. Right? That's what we would have. But here we have this angle. Now we could also find this angle here, call it alpha. Now what would alpha be? Because the thing is, if you should differentiate the formula, D is equal to H over tan theta. I don't remember, or I don't know what, if it is there at all, what the derivative of cotangent is. Alright? This would be the cotangent. So what I'm going to do is look at the other angle, right? Look at using the other angle. No, this angle plus alpha would be 100 and no, it would be 90 degrees, right? So let's use that. Now 90 minus 45 plus 0.5 and 90 plus minus 45 minus 0.5. What would these be? Let's reach for our calculator here. Calculator. 90 minus 45 is of course 45. Oh, it should be 90 minus 45 is of course 45. Plus 0.5. We do that again. Plus 0.5. It's 45.5. And then 45 minus 0.5 will be 44.5. So it's still 45 plus or minus 0.5, right? You see that? So in this case, let me redraw the cliff and the jet ski and so on, but we simplify it with using a triangle. This angle right here is also 45 plus or minus 0.5. Alright? We have height and we have D. H. Let's use lowercase h and D. Now, D is what we want. Now, tan 45 equal opposite, which would be D over adjacent H. So D would be H tan 45, which is theta. I told you, and I do it myself though. Not when we want the formula. But don't put in the numbers in the formula. Put in just letters because we want a general formula. Alright? Now, the nominal value D would be H, which is 45, times the tan of 45 degrees. Now the fact is, if you convert this to radians and put your calculator in radian mode, find the tan, you get the same thing as in degree mode and find 45. So 45 tan is 1. And if you put it in radian, and you say 45 times pi over 180 equal, when you tan this, you get the same one, right? So it's 45 by 1, which gives us 45 meters. That's the nominal value. It will be the average value between 45 going up by 0.5 and 45 going down by 0.5. In other words, the average value of 45 plus or minus 0.5, right? Now, we want to write down the formula relating the partial derivatives and the differential. Now, the differential in h, that adjustment, that h, that change in h is equal to the partial derivative of h with respect. Oh, it's d, d, not h, right? It's d. Alright, so remember, we want to find what d is. D, there is some adjustment in d, which we call the delta d. So a small change in d is equal to the partial derivative of d with respect to h times a small change in h plus partial derivative of d with respect to theta times a small change in theta. Alright? Now, this is the formula that we're going to look at when we're doing the partial derivative. So, partial of d with respect to h equal, what do you get? Tan theta. Partial of d with respect to theta is going to be h sec squared theta. Alright? Remember, the derivative of tan theta is sec squared theta. If you remember the table of derivative that has x or tan x on the left, when you look in the derivative part, you say sec squared x. And then h, we treat it as if it's just a constant, so it's h times sec squared theta. Now, what is delta h? The change in h is 0.5 meters, right? And then the change in theta is equal to, now this part you cannot have it in degree, it must be in radians, alright? 0.5 pi over 180 is 0.5 pi over 180 in radians, right? So that small change in d is equal to the delta by dh, which is tan theta times change in h plus h sec squared theta times the change in theta. Let's put in all the numbers now. So that small change in d is equal to tan is 45, but let's use radians. 45 pi over 180 radians times small change in h. Hold on. The small change in h is what? What did the question say? Height 0.5. Oh, it's 350 plus or minus 0.2. Yeah, it is the angle that changed by 0.5, yeah. But the small change in h is 0.2. I'll put 0.5 here. 0.2, alright? Times 0.2 plus height 350 times sec square theta. The angle theta is 45 pi over 180 radians, and that you multiply by the small change in thing there in the angle, which is 0.5 pi over 180. So we do a calculation. Changing d is equal to tan of 45 in degree is 1. And the tan of 45 pi over 180 is also going to be 1. So you're just going to have 0.2 here, because it's 1 by 0.2. Alright, so you have 0.2 plus 350 times, alright, so 6 square 45. So we have 6 square of all of this in, let's work it out in radians. 6 square of 45 multiplied by pi over 180 equal. Now sec means 1 over cos. So we find cos of this, we get 0.707. 1 over it, we get that. And then square it and you get 2. Alright? So this amounts to 2. And then what is 0.5 pi over 180? So we have 0.5 times pi over 180 equal 0.00873. When you round it off, 0.00873. So 0.2 by 0.00873. So the change in D is equal to, alright, so let's get back to it now. Okay, let's clear the calculator and deal with this. 0.2, oh no, let's clear again. 0.2 plus, alright, 350 multiplied by 2 multiplied by 0.00873 equal 6.311. So 6.311. Alright. So the distance D is equal to, what was it again? 350. 350 plus or minus 6.3 meters if you wrap of it to one decimal place. What do I have up here? 6 point, yeah, this would be to 6.32 if you work it out. Alright, so that's it for now. I'll see you in the next video.